You want to build a voice assistant in Python on Azure, and the first thing every tutorial skips is the decision that actually shapes your project. How do you wire speech to the model? There are two real paths. One is a chained pipeline, where Azure AI Speech does speech-to-text, Azure OpenAI generates a reply, and Azure AI Speech does text-to-speech. The other is the Azure OpenAI Realtime API, a single speech-to-speech connection. In this video, I'll lay out the criteria that matter, where each path fits, and a recommendation you can act on. The chained pipeline gives you 3 discrete steps you fully control. You transcribe audio with the Speech SDK, send text to a chat completion, then synthesize the answer with neural text-to-speech. Every stage is observable, swappable, and cheap to reason about. The Realtime API collapses all of that into one WebSocket session. The model hears audio and speaks back directly, handling turn detection and interruptions for you. The trade is control versus simplicity and latency. Chained means more moving parts but full visibility. Real-time means lower latency and natural interruption, but less insight into each stage. Before picking, weigh 4 things. First, latency. Humans notice gaps over about 800 milliseconds, and a chained pipeline stacks recognition, model, and synthesis time. Second, barge-in. Can the user interrupt mid-sentence? That's free in real time, but you must build it in a chain design. Third, observability and compliance. If you need transcripts, content filtering on text, or function calling you can inspect, the chained pipeline wins. Fourth, cost. Real-time audio tokens are built differently from text plus per character speech, so model your expected minutes. Pick based on which of these dominates your use case, not on novelty. Here's the chain design most teams start with. The client streams microphone audio to your Python service. Azure AI Speech returns recognized text, which you send to Azure OpenAI with your system prompt and any tools. The model's reply goes to Azure AI Speech neural text-to-speech, and you stream synthesized audio back. Put Key Vault in front of your keys, and if you need grounding, slot Azure AI search between the transcript and the model for retrieval. This shape is easy to test stage by stage and lets you log every transcript and completion for evaluation. To keep the chained pipeline fast, use continuous streaming recognition instead of waiting for the full utterance. The Speech SDK emits partial and final results as the user talks, so you can fire the model call the moment speech stops. Here's the core setup. Notice we use a recognized callback rather than a single blocking recognized call, and you'd kick off the Azure OpenAI request inside that handler. Pair this with streamed token output and chunked synthesis to overlap stages and shave hundreds of milliseconds. Always pull keys from Key Vault, never hard code them like a quick start. The reply side is where assistance feels slow or robotic. Use Azure AI Speech neural voices, and stream synthesis as the model emits tokens rather than waiting for the whole sentence. Speech Synthesis Markup Language (SSML) lets you control pace, pauses, and pronunciation, which matters for numbers and brand names. If you need a custom voice or a specific accent, check the current voice gallery in the Azure docs, since the catalog and pricing change often. A practical rule of thumb: start synthesizing on the first clause, and you'll cut perceived latency dramatically without changing your model. Choose the chained pipeline when you need transcripts, retrieval grounding, content filtering on text, or tight per stage cost control, and when a 1 to 2 second response is acceptable. Reach for the Azure OpenAI Realtime API when conversation fields are the product. Low latency back and forth, natural interruptions, and emotional voice. Think live customer support or hands-free copilots. The cost is reduced visibility into intermediate text and a newer, evolving feature set, so confirm regional availability and supported models in the current Azure docs before committing. Many teams ship the chained version first, then migrate hot paths to real-time. So the decision comes down to control versus conversational latency. Default to the chain pipeline of Azure AI Speech, Azure OpenAI, and neural text-to-speech when you need observability, grounding, and cost predictability. Move to the Realtime API when interruption and sub-second responses define the experience. Your concrete next step: build the chained version with continuous recognition and streamed synthesis. Then measure end-to-end latency before you optimize anything. If you blow your latency budget on hot paths, prototype those in real time. And because pricing, voices, and real-time availability shift, always verify against the current Azure documentation. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.